Hi everyone, welcome to another video, and today we're going to discuss about a new question related to our prefix sum. It is the question number 74 of our lit code, and the question reads as given an array of integers called nums, and we have to calculate the pivot index. So what is the pivot index? The pivot index is the index where the sum of all the numbers strictly to the left of the index is equals to the sum of all the numbers to the right of that index. And if the index is at the edge, either to left or right, then the left sum is 0 because there are no elements to the left. This also applies to the right edge of the array. Return the leftmost pivot index if no such index exists. Return -1. So let's understand the question. Let's go with example 1, where the nums array is given as 1, 7, 3, 6, 5, 6. Okay, so what it says, that let's assume that the pivot index, or take that pivot index is at 3, right? The indexes are 0, 1, 2, 3, 4, and 5. So why 3 will be the pivot index? Because the sum of all the elements to the left of index 3, right? Like sum of left is equals to sum of all the element to the right of that index, sum of right. It means 1 plus 7 plus 3, that is 7, 1, 8, that is 11, equals to 5 plus 6, that is 11. When this condition satisfies for any index, right, from 0 to 5, for any index, this condition satisfies, we can call it a pivot index. So all the element to the left, sum of all the element to the left should be equals to sum of all the element to the right. So let's write down the given question again. For question number, the example 1, the nums are like nums array is 1, 7, 3, 6, 5, 6. So we have to match the sum from the left, then we have to match the sum from the right for every element. So we need to create a prefix sum from the left, and we need to create a prefix sum from the right, and just we have to compare the element. It's simple as that. Let's see. For example, we're going to create a cumulative sum or prefix sum from left. Okay, that will become like 1 plus 7, 8, then 8 plus 3 become 11, then 11 plus 6 will become 17, 17 plus 5 will become 22. Yes, 22 plus 6 will become 28. Similarly, we're going to create another CS array from right, and that will become like 6 plus 5, 11, 11 plus 6 will become 17, 17, then 17 plus 3 become 20, 20 plus 7 will become 27, 27 plus 1 will become 28, right? Now what we have to do, then again we have to iterate through this nums array, right? For every index, for index 1, we're gonna, the left to the 0th index will be 0, and right to the sum of the elements are right of the rightmost index will be 0, right? So once we go to 0th index, we're going to check what is the sum from right side. 27 from left side 0, so it's not the same. Similarly, we're going to keep going. When we reach at index number 0, 1, 2, 3, 4, 5, index number 3, then we'll find that CS, like index I plus 1, that is 11 here, that is 11, and the sum to the left of that index, we're gonna take that amount from the CS left, that will give us 11. So for every index, we're gonna check the sum to the right from the CS array from the right, and we're going to check sum to the left from the CS array left, and wherever that it matches, that is our index, and that's how we're going to solve it. So similarly, we're going to include the edge case as 0. So every time while calculating the left and right value, right, the sum to the left and sum to the right, if our index is less than 0, we're going to reset it to 0. And then if the index is the rightmost index, when we are checking for I plus 1 value, that is the right sum value, we're going to reset it to 0, and that will give us the answer. So then let's try to implement the solution using JavaScript, right? Then first thing first, right, we need to create two prefix sum array, one from the left and another from the right. So now let's do that. So let's create two array, and array of the same length as our input nums, right? So let cumulative sum left equals to array of nums dot length, and we're gonna fill it with 0. Similarly, we're gonna create let CS from right, and same thing, nums dot length, we're gonna fill it with fill it with 0. And now we're going to write a for loop to create our CS left array. Then again, we're going to write another for loop to create our CSR array. So let's go for the CSL array, like for let I equal to 0, I less than nums dot length I plus plus is fine. And then for the first index, we don't have to do anything, so we can write like for if I equals to 0, then we just have to populate the same amount, the CSL of I equals to nums of I. So this will add the first item, else we have to do CSLI equals to nums of I plus CSL I minus 1. So this will give us our CSL array. Similarly, we're going to calculate our CSR array from right side. So let's go for it. For we're gonna put j, and j will start here from nums dot length minus 1. J will be, we're gonna go up to j greater than equals to 0. Then you do j minus minus, and we're gonna populate the last index as this, as same as our nums of nums array. So if j equals to nums dot length minus 1, then csr of I equals to nums of I. This will populate our last item same as our nums array. Else we have to do like csr of I equals to nums of I plus csr I plus 1. So this will give us the cumulative sum array from the right side. One is from the left side and another from the right side. And now we need to, in second step, like we need to compare the sum to the left and to the right to get result, right? So we're gonna run another for loop here that will go from I to nums dot length, then I plus plus. Now here we're gonna calculate our left and right. Let left equals to, if I minus 1 is less than 0, then we have to return 0, else we have to return left value is cumulative sum L of I minus 1. This will be our left value. Similarly, let right value will be if I plus 1 is greater than nums dot length minus 1. Then we have to return 0, else we have to return our value from the CSR array, right? CSR of I plus 1. So we get our left and right value. Now we have to check, like, if left equals to right, return index. So this will be our result pivot element, pivot index. If we did not get any pivot, then we have to just return minus 1. So this should solve our question. Now I have written the test cases for all the edge cases. One is for example 1, second one is example 2, where we don't have a pivot element. Then third one is when the pivot element is at the left edge, and the fourth one is when the pivot element is the rightmost index, right? So let's run it. What is the CSJ here again, man? So we are calculating a J and I have written it I. That is the wrong thing. J. Perfect. Say again, I. Fine. So it has passed. Now let's test our solution in the lit code. Let's copy it. Run the test cases. Test cases are passing. Now let's submit. So this is one of the most efficient solutions. So we are good. So that's that. Thanks for watching and see you in our next video.